Have you ever just stepped outside on a crisp, clear night, looked up, and felt this undeniable, profound pull? For centuries, gazing up at the cosmos has drawn us out into the dark, one by one, to just soak in the breathtaking beauty and complexity of the universe. Today, we're going to learn how to read that night sky, figure out the tools you need to unlock its secrets, and explore exactly why looking up might just be one of the most enriching experiences we can possibly have.
Okay, let's dive right into this with a totally brilliant observation from the philosopher Bertrand Russell. When we ask those massive questions, like what is our actual role in the universe, we kind of tend to get caught up in our own egos. But Russell beautifully points out that nature doesn't really care about making us happy or unhappy. Observing the sheer infinity of the sky instantly brings our human self-importance right back down to Earth. It's literally the ultimate reality check.
But there's a huge modern barrier to this cosmic connection, and that's light pollution, or light smog. For so many of us living in urban areas, artificial light just completely drowns out the night sky. The stars, and even that brilliant band of the Milky Way, are barely even visible anymore. And this isn't just a minor annoyance for astronomers, It physically disconnects us from the vast cosmos, and all those age-old questions it naturally inspires. We literally forget to look up because, frankly, there's just less to see.
So, to truly appreciate what we're missing, we need to look back. Let's move into part 1, from myth to mathematics, the human journey. This timeline maps out an absolutely incredible human journey. All the way back around 3000 BC, Babylonian priests were charting the stars. They actually believed them to be gods, which effectively merged astronomy with astrology. Fast forward a bit to 2000 BC in Central Europe, and we find the Nebra sky disk. This is the oldest known representation of the night sky, and it clearly depicts the Pleiades star cluster. Then came the ancient Greeks, who shifted the whole paradigm from myth to logical, rational science. But the really massive leap, that happened in 1609, when Galileo turned a telescope skyward, completely launching the scientific enlightenment. And ultimately, it was Isaac Newton who revolutionized our understanding by discovering gravity. He replaced those wildly complicated ancient theories of circular planetary epicycles with the actual, true mechanics of the cosmos.
And this brilliantly illustrates just how far we've actually come. Consider this for a second. The absolute worst, cheapest department store telescope you can buy today is vastly superior to the instrument Galileo used. Galileo didn't even invent the telescope. Dutch lens makers actually did that. But he was the very first person to point it at the night sky. And even with his incredibly primitive tool, he discovered Jupiter's moons. That proved for sure that not everything revolved around the Earth. He also observed the phases of Venus, proving it orbited the Sun. The tools we have access to today are exponentially more powerful, making the universe way more accessible to you than it ever was to the greatest minds of the 17th century. So how do you actually take advantage of this accessibility? Let's shift gears a bit to part 2, choosing your optical tools, a practical guide.
If you want to get started, you really need to follow these steps. Please do not jump straight to step 3. Step 1 is simply using your naked eye and a star chart app on your phone. You have to get your bearings first. Learning key reference points, like the North Star and the Big Dipper, is absolutely essential before you spend a dime. You wouldn't buy a sports car before learning how to drive, right? Step 2, get a decent pair of binoculars. You'll be amazed at how much more you can see compared to just the naked eye alone. Only after you're totally comfortable navigating the sky should you move to step 3, an entry-level telescope, which is typically going to run you between 300 and 500 euros for a solid starting instrument.
Once you're ready for that telescope, you're generally going to be choosing between 2 main technologies. First, you have the refractor telescope. Think of this as the modern descendant of Galileo's tool. It uses lenses to bend light, offering an incredibly sharp, high-contrast image. The downside, though? Well, getting a large enough lens to see very faint, deep-sky objects gets incredibly heavy, bulky, and really expensive. On the flip side, we have the reflector telescope. Instead of lenses, it uses mirrors to gather light, which completely avoids the color distortion that can sometimes happen with lenses. Reflectors offer excellent light-gathering power and usually represent the absolute best value for money if you're a hobbyist.
Now, I want to give you a few crucial buying tips, and I cannot stress this enough. Avoid the cheap discount store bargains. Why? It all comes down to the mount. A telescope is quite literally only as good as the mount holding it. Because the Earth is constantly rotating, the sky appears to move. So when you're zoomed way in on a planet, it's going to drift right out of your view unless your mount smoothly tracks that celestial rotation. A cheap, wobbly mount is going to frustrate you so much that it will quickly kill your dream of exploring the stars. So invest in a sturdy mount And always make sure you actually have the space to store and transport your gear to a dark location.
But hey, what if you aren't quite ready to buy your own gear, or you just want to learn from the pros first? Well, that brings us to part 3, bringing stars to Earth, the communal sky.
Back at the end of the 19th and early 20th centuries, there was this massive movement to bring cutting-edge scientific discoveries to ordinary citizens. Pioneering institutions like the Urania Society and the Untold Observatory in Berlin and the Zeiss Society in Jena were founded purely to expand public education. Today, incredible places like the ESO Supernova Planetarium in Munich are keeping this legacy alive. These public observatories give everyday people a literal peephole into the depths of space. Seeing the rings of Saturn or the moons of Jupiter with your own eyes while surrounded by a really knowledgeable community is an experience that will leave you absolutely spellbound for the rest of your life.
Inside planetariums, the magic is driven by some truly incredible technology. Optomechanical star projectors use highly complex lenses, mirrors, and precision mechanics to create a flawless illusion of the night sky. The very first star projector was actually presented to the public back in 1925 at the Deutsches Museum in Munich, an idea that was championed by its founder Oskar von Miller. And unlike purely digital screens, these optomechanical miracle machines reproduce celestial objects with absolute precision. We're talking right down to the true-to-life flickering of the individual stars. It is honestly as close to being in deep space as you can get right here on Earth.
So, the crucial point is how this incredible realism is actually achieved. Consider this ratio, 1 to 400. That is the number of individual optical fibers threaded onto a single star plate inside a modern Zeiss projector. And here is the truly mind-blowing part. Every single one of those fibers, which by the way are thinner than a human hair, is threaded by hand under a microscope by a specialist known as a star threader. Each fiber represents a single fixed star. It requires just an unfathomable level of skill, a rock-steady hand, and infinite patience to build these machines that manage to bundle the entire complexity of the night sky into a single device.
And speaking of people dedicating their time to the stars, you don't actually have to be a professional with a PhD to make a real impact. Let's move to part 4, the power of citizen science, joining the cosmic quest.
Unpaid amateurs are actively contributing to cutting-edge professional science right now. Take these remarkable projects, for instance. With Einstein at home, 500,000 everyday people share their home computing power to help scientists process vast amounts of data to detect gravitational waves. In another amazing project, amateurs are analyzing historical, hand-drawn sunspot records from the 1800s, which helps researchers at the Max Planck Institute understand the 11-year cycle of solar activity. And remarkably, amateurs are still out there discovering new celestial bodies. In 2023, an amateur astronomer named Josh John was examining a star field and noticed this bright, diffuse object. Well, it turned out to be a previously unknown periodic comet. The International Astronomical Union officially named it P/2023 C. Jane. So his name is permanently etched into the cosmos. How cool is that?
To truly grasp the scale of what we're exploring here, consider this number: 1 billion. Scientists estimate that if you go to the beach and scoop up a single handful of sand, you're holding roughly 1 billion individual grains. Now, I want you to imagine all the sand on all the beaches and in all the deserts across the entire world. It's a completely incomprehensible amount. And yet, there are more stars out there in the infinite universe than there are grains of sand on all of Earth combined. That's enough to just blow your mind. And out of all of that vastness, we currently only know of one single grain of sand, our own little solar system, where life exists.
Which brings us right back to where we started. You see, when you look up at night, the universe is no longer just a scattering of white dots. It's a dynamic, awe-inspiring story of our origins. Stargazing is a journey that reaches deep into the past and forces us to ask, where do we come from? Where are we headed? And are we truly alone in this infinite universe? Exploring the night sky might just be the absolute best way to gain orientation, knowledge, and a much-needed sense of stability in our fast-paced world.